All right, so we're going to get started now with the next phase of developing this game, and that is actually making it so that the user interaction with the sprites makes makes sense in the context of the air hockey game that we're trying to build. I am going to be talking a little bit about the math and physics here, about how I'm pulling off what I'm doing. Don't be scared, it's going to be fine. I'm just going to give you enough info so that you have the context you need to understand what I'm trying to do. So the first thing that I want to bring your attention to is this function that runs when we drag our finger across the screen. And for this, we're using the touches moved function. And so what we're doing in this code is that if there is a location where we are touching the screen, we're going to get the first location where that happens. And we're just going to set the location of the red player's sprite, the position of the red player's sprite, equal to the location of that touch. This is exactly the same as some of the code that you did in the sprite kit explorations. So let's see how that works. So if I run the code, you can now see when I drag around on the screen, that red sprite moves around beautifully. So I know that that is working the way I want it. Okay, the next thing that I want to show is this. So this function runs anytime two sprites are in contact with each other. And so what I want to do here is I want to make it so that if there is contact between two sprites, and one of those sprites is the puck, and the second of those sprites is the red player. What I want to do is I want to apply a force to the puck. Now here's the thing. There's some limitations of SpriteKit in how we're going to go about this. I'll show you really quickly. If I turn this off, this code that I've written, and I run this, when I bump into that, it kind of doesn't really move. It just pushes that puck around, and that is not at all what I want. Instead, what I want to do is I want to figure out when I am coming at that puck from a certain location, I want to give the puck a push so that it glides across the surface of the table just like a real puck would. And so let's talk just for a moment about what this means right here and what it is that I'm doing in this calculation. All right, so this is the mathematical part. Again, don't be scared. I just want you to understand a little bit of what it is we're trying to do with this. So I want you to imagine a couple different scenarios that we're going to use this idea to figure out. One is when, imagine this is my sprite and I am going after the puck. And I want to know when I go after it, I want to be able to give it a push that goes in the direction of where I'm coming at it from. And so the way I do that is I actually want to compare the position of the red player and the position of the puck itself. So I'm going to look at the coordinates of this. So there's going to be an X and Y coordinate there. And I'm going to look at the X and Y coordinates of the puck as well. And we're going to be using something called a vector to compare these two things. So we're going to look at this distance right here that we're going to call our dx or our delta x. And we're going to be looking at this right here, which is our dy. If I make this y2 and x2, and I make this y1 and x1, we can actually figure out what these two quantities, dx and dy, are going to be. dy here is going to be y2 minus y1, and dx here is going to be x2 minus x1. Now, you have seen this before. This is, you may have seen this in the context of the slope formula. You may have seen it in the Pythagorean theorem. In either case, all we are doing is trying to figure out the size of this. Now, there are a couple reasons why we want to do this. One thing is, when we are applying a force, we're going to apply a force that is proportional to this distance right here in the y direction, and we're going to apply a force that is proportional to this distance in the x direction. And what that's going to do is push our puck in the correct direction depending on where we are approaching it from. So if we're coming from this side over here, our dx and dy will be such that this is going to be pushed in the direction that this is headed. If we're coming from this direction, the reverse will happen. The other thing that we're going to try to do, because we're dealing with vectors, we're going to also be figuring out the movement of the puck. Not the puck, the red player. Because SpriteKit doesn't actually, when you are moving the thing around the screen, SpriteKit doesn't let you set the velocity in terms of physics of the red player. It says, oh, the user is grabbing the sprite and moving it around. We can't calculate physics on it because right now there's some non-physics bound force that's managing all of this. So what we are going to do to figure this out is we're going to compare the location of the red sprite in one frame compared to the previous one. And we're going to use that to figure out how fast the red player is moving. You might know this calculation. V is delta x over delta t. This is how you calculate average speed. In the case of this just being distance, we're going to be using this to calculate that speed and then apply a force that uses this dy and dx accordingly to get it moving in the right direction. All right, enough of this. Let's see how this works in the code. All right, so there are two things based on what I just showed you that we want to pull off. The first thing is we want to find the speed of the red player, and we're going to do that by calculating its change in position between two frames. So we're going to do a few things to make this work. Let's find the speed of red player sprite. The first thing we're going to do is we're going to go up top and we're going to create a couple variables. One is red player speed, that's this right here, and also the previous red player position. And I'm setting both of these equal to 0 at the start of my game. The previous red player position is a point, and I'm just setting its initial value equal to 0, 0. This is going to get overwritten pretty quickly as we get started. And so to find the speed, what I'm going to do is I'm going to calculate that delta x that you saw in my whiteboard work, and I'm going to calculate delta y. And I'm going to get this by doing the red player sprite.position.x, subtracting the previous red player position.x. That's for delta x, and that's the difference between x2 and x1 that I showed you on the board, and same thing with dy. So the first thing that we're doing is we're calculating a change in position. The second thing that we're doing is we want to be able to see the current position of the red player sprite in the next frame of the game. This function, remember, runs every frame of the game after it has calculated everything, and so we want to compare in each frame the current location with the red sprite with the previous. So I'm going to do this. And the last thing that I'm going to do is I'm going to calculate the speed using the Pythagorean theorem. This is the Pythagorean theorem, but it's a little hidden. It certainly doesn't look like a giant square root, but this is the square root function, and inside of it I am doing the delta x squared, so that's kind of the a squared in Pythagorean theorem, plus the delta y squared in Pythagorean theorem. And I wrote the multiplication this way so that it would be very clear that I'm squaring delta x and adding it to the square of delta y, taking the square root and getting the speed. So I am calculating this every frame. The next thing that I'm doing, getting back to this didBegin function, is I'm going to, again, check, is body A the puck and is body B red player? Because if so, I'm going to name the puck body A. I'm going to get the position of the puck here, and I'm going to get the position of body B, which is the red player, here. And now what I'm going to do is I'm going to apply an impulse. An impulse is a little, it's a force over time. So I'm going to apply a little push. The X component of this is going to be this number that I've put in called force constant, which I forgot to say that I put in here, up here. Force constant is right here. I've set this to be 0.03. Okay, and so I'm taking force constant, I'm multiplying that constant by the speed, and then right here is that x2 minus x1 again that I talked about before, y2 minus y1. And so the end result of having all of these things together, when I run the code, let's make it nice and big, when I run the code is I can grab my red player sprite, move it around as before, and I can give that puck a little push. And you'll notice it slides, oh, so close. If I come at it faster, we get a higher speed. And if it's coming at me and I kind of back up, let's try that a slightly different way. Okay. If I come at it and I'm not moving so fast, it doesn't tend to ricochet so much. So watch that. So in that, where it's just barely moving, it kind of bounces. So this is having the physics that I want, and now I can start getting into the other parts of this working. All right, nice work, everybody.